Hi guys, this video is gonna tell you something about the ozone layer and the facts behind it. Ozone layer is also called as ozonosphere. This is the region of the upper atmosphere which is roughly 15 to 35 kilometers above Earth's surface, which consists of high concentrations of ozone molecules, which is nothing but O3. The production of ozone in the stratosphere results primarily from the breaking of chemical bonds within oxygen molecules by high energy solar photons. This process is called photodissociation, which results in the release of a single oxygen atom which later will join with intact oxygen molecules to form ozone. The thickness of the ozone layer varies worldwide and is generally thinner near the equator and thicker near the poles. Thickness refers to how much ozone is in a column over a given area and varies from season to season. The reason for these variations are atmospheric circulation patterns and solar intensity. In the stratosphere, the temperature of the atmosphere rises with increasing height, a phenomenon created by the absorption of solar radiation by the ozone layer. The ozone layer effectively blocks almost all solar radiation of wavelength less than 290 nanometers from reaching the Earth's surface, including certain types of ultraviolet and other forms of radiation that could injure or kill most living things. The ozone layer was discovered in 1913 by the French physicists Charles Fabry and Henri Boison. Measurements of the sun showed that the radiation sent out from its surface and reaching the ground on Earth is usually consistent with the spectrum of a black body, with the temperature in the range of 5500 to 6000 Kelvin, except that there was no radiation below a wavelength of about 310 nanometers at the ultraviolet end of the spectrum. It was deduced that the missing radiation was being absorbed by something in the atmosphere. Eventually, the spectrum of the missing radiation was matched only to one known chemical, that is ozone. Its properties were explored in detail by the British meteorologist G.M.B. Dobson, who developed a simple spectrophotometer which could be used to measure stratospheric ozone from the ground. Between 1928 and 1958, Dobson established a worldwide network of ozone monitoring stations which continue to operate to this day. Rising atmospheric oxygen concentrations some 2 billion years ago allowed ozone to build up in Earth's atmosphere, a process that gradually led to the formation of the stratosphere. Scientists believe that the formation of the ozone layer played an important role in the development of life on Earth. By screening out lethal levels of UVB radiation and facilitating in the migration of life forms from the oceans to land. The ozone layer can be depleted by free radical catalysts including nitric oxide, nitrous oxide, hydroxyl, atomic chlorine and atomic bromine. While there are natural resources for all these species, the concentration of chlorine and bromine increased markedly in recent decades because of the release of large quantities of man-made organohalogen compounds, especially chlorofluorocarbons and bromofluorocarbons. These highly stable compounds are capable of surviving the rise to the stratosphere, where chlorine and bromine radicals are liberated by the action of ultraviolet light. Each radical is then free to initiate and catalyze a chain reaction capable of breaking down over 1 lakh oxygen molecules. By 2009, Nitrous oxide was the largest ozone depleting substance emitted through human activities. The breakdown of ozone in the stratosphere results in reduced absorption of ultraviolet radiation. Consequently, unabsorbed and dangerous ultraviolet radiation is able to reach the Earth's surface at a higher intensity. Ozone levels have dropped by a worldwide average of about 4% since the late 1970s. For approximately 5% of the Earth's surface around the North and South poles, much larger seasonal declines have been seen and are described as ozone holes. The discovery of the annual depletion of ozone above the Antarctic was first announced by Joe Farman, Brian Gardner, and Jonathan Shanklin. The Antarctic ozone hole forms every year because winter temperatures in the area routinely plummet, allowing the higher altitude clouds to form. These conditions are much rarer in the Arctic, which has more variable temperatures and isn't usually primed for ozone depletion. But this year, powerful westerly winds flowed around the North Pole and trapped cold air within a polar vortex. There was more cold air above the Arctic than in any winter. In the chilly temperatures, the higher altitude clouds formed and the ozone destroying reactions began. Researchers measure ozone levels by releasing weather balloons from observing stations. By late March, these balloons measured a 90% drop in ozone at an altitude of 80 kilometers, which is right in the heart of the ozone layer. Where the balloons would normally measure around 3.5 parts per million of ozone, they recorded only around 0.3 parts per million. That beats any ozone loss we have seen in the past. The Arctic experienced ozone depletion in 1997 and in 2011, but this year's loss looks on track to surpass those. Things would have been much worse this year if nations had not come together in 1987 to pass the Montreal Protocol. The Antarctic ozone hole is now on its way to recovery. Last year's hole was the smallest on record, but it will take decades for the chemicals to completely disappear from the atmosphere. In March, scientists had noticed signs of a hole forming in the ozone layer above the North Pole and thought it was the result of low temperatures. It is believed to be the largest hole in the ozone layer and would have led to a bigger threat had it moved towards the south. However, scientists have confirmed that the 1 million square kilometer wide hole in the ozone layer has been healed. They added that the closing of the hole was not due to the reduced level of pollution during the coronavirus lockdown. It is believed that the polar vortex, the high altitude currents that are responsible for bringing cold air to the polar regions and is responsible for the healing of the layer. Hope you all had an informative session. Thank you. See you in the next video.